Usually, a river flowing down the hill would have a specific force with an enormous amount of pressure. Thereby comes the beaver, which is known for building dams, acts as a resistance for reducing the flow of the river, nothing but the current flowing through the circuit. Finally, what you conclude from this description? It is nothing but the Ohm's law. Since the current flowing through the circuit is directly proportional to the voltage, and inversely proportional to the resistance, which is I equals V by R. Correspondingly, when we increase the voltage, the current will increase, but when we increase the resistance, the current will decrease. A group of friends was so much attracted to the flow of water down the hill, so they were desired to see its origin. All the three started to climb the mountain. At one point, there appeared a confusion for them about which path to choose, as there were three paths in front of them. In that, three of them decided to go on each track, considered as inputs. These three ways have a common exit point as outputs. After a while, three of them met at the exit point, by which the given input is equal to the output, which is similar to the Kirchhoff's current law, as it states that the total current entering a circuit's junction is precisely equal to the total current leaving the same junction. Consider a train moving from a point on a track, passing through four different stations in the clockwise direction, which could be assumed as voltage, inductor, and capacitor. After crossing all these four various positions, it will come back to its same point, like a closed loop. If the train is arriving early, it would be depicted as the positive sign, and for being late, the sign will be negative. From this, we could arrive at Kirchhoff's voltage law, where the algebraic sum of all the voltages around any closed loop in a circuit is equal to 0.